All right, so good morning. Today we'll have our last lecture for this module. I will explain the last two lab sheets, which essentially will be the OVS Open Nebula Networking lab sheet, and then the last one, which is building the cloud. So the first lab sheet, the Open Nebula Networking one, is perhaps one of the more complicated ones for this module because you will have to create the networking infrastructure for all of your cloud systems so that you can actually connect all of the virtual machines between them and to the outside world. Now, in order to do this, we will use a piece of software that's called OpenVSwitch. So this is one of the methods that you can do networking in OpenNebula, and in theory, and I think in practice as well, it's the most efficient and the most capable way of networking everything inside your cloud. So this software, at this particular version that we're using for these lab sheets, the installation process of it is slightly convoluted, I will say. All right. It's not just an RPM that you can download and install on the system. You actually have to create the RPM pretty much from source in order to do it. Plus, there is a big number of dependencies of things that actually need to be in place for it to work. So in order to do this, we'll start by clicking on this link so that you can actually download the file. The file is an archive, it's a tar.gz file. So once you download this in your downloads folder, you will need to basically extract it, and it will be extracted into a folder called OpenVSwitch2150. You will need to go into that folder and you'll need to open a terminal in there, and all of the commands that you will type for this lab sheet will pretty much need to happen in there. There are some of the commands that don't really depend on this, like the yum install commands and everything, but there are some commands, especially the next ones, the boot configure, make dist, and all the copy commands after those, that really depend on you being in the correct location. So I'd rather from the beginning that you go into this folder and everything you do actually happens inside this folder to make things easier. So once you download and extract the archive, you then use yum install in order to install this very long list of dependencies. Now, your systems might have some of them already because of the type of installation that you made. We're just double checking that you actually have everything necessary. We're not assuming that you have some of these already. So just basically copy and paste these commands from here onto your terminal to make sure that they install. Yes, we could have done a yum install 4 lines of packages. However, it's been shown in the past that students will just copy and paste everything, and then the system will not actually paste in a terminal more than 1 line at a time. All right, so that's why there are 4 different commands so that you can fit each command in a line. Another detail about this lab sheet is I've tried to make it as bulletproof as possible, to the point that especially the installation of the software, you don't really even have to understand what's happening. If you just copy and paste all of the commands onto a terminal one by one, then other than you being in the correct folder to do everything else just sort of works. Okay. However, I do want you in your logbook to explain what's happening in each of the screenshots when you copy and paste each of the commands. Okay, it's perhaps even more important in this one rather than the previous ones. So we do yum install for all of these packages, we get them installed, and then once this is successfully completed, you then go and you run the boot shell script, the configure script, and then you make dist. So this method of installing something is called installing from source. So essentially, there are a couple of scripts that will tell the system how to compile the code from the software and make the files, the executable file for the program, available for your computer. Now, once boot, configure, and make dist actually completes, they shouldn't take too long to run. You can then use those 2 commands. So you will make a directory that is called RPM build, and inside it will include the subdirectories sources, build, RPMs, specs, and SRPMs. So that's what this command does. And then you will copy the tar.gz that you downloaded, or that is there actually, into the sources folder. Once you do that, you're then ready to build the RPM for your system. So this command, the RPM build command, will actually take the source files that you've downloaded and everything that you've created with the boot configure make install, and it will create the RPM that is needed for your system. This command will run for a while. Alright, so it takes about 2 or 3 minutes if I remember correctly, and you'll just see endless code scrolling, so the process scrolling on the terminal as this happens. Of course, it goes without saying, I don't need screenshots of this. Just one screenshot of you typing the command should do it. Okay, so you don't need to worry about this. Once this finishes, you can then do the command yum local install and use the RPM that is located in RPMs x8664, and the RPM is called OpenVSwitch215 and so on. So that will actually install the software onto your system, and you will then be ready to use it. To use it, you enable it first of all so that it starts every time you start your computer automatically, and then of course you can start it just like any other service, open vSwitch onto the system, and it will run. To verify that it's installed and it's running correctly, the most basic command that you can do with this is OVS VCTL show. That will show you the version of OVS that is installed, and it will actually show you any interfaces that you have configured, which at the moment is none, but at the very least it should show you that yes, OVS is installed, it's in version 2.15, and you're good to go. Once you cross this checkpoint, you are then ready to start configuring the program itself. So the first thing that we need to do is we need to change a little bit the network card configuration that we have in our system. So at the moment you will have an ENS33 that is bridged to BR0. BR0 will have the IP address. ENS33 will be starting without an IP address. So we are going to change this. Essentially, we're going to make a few changes, and we're going to use BR0, and we're going to replace it with a network card called Net28. This is because after that we will also create Net30, 31, and 32. So we want all of our virtual network cards to have sort of the same naming structure. In order to do this, and for everything to work, we need to first of all configure OVS for this purpose. So we need to type OVS VCTL add bridge. The bridge is going to be called VMNet28, and then we're going to add a port into this bridge, and that port is going to be called Net28, and then we're going to add another port called ENS33. At this point, the system will most probably complain, and it will say port not found, blah blah blah. You can ignore this. Okay, this is because what you're trying to add in OVS, the devices that you try to add in OVS, don't actually correspond to the correct devices as they should have been inside the etc. sysconfig network scripts folder. So in order to fix this, you need to go into those folders and create the two files. The one of them is the BR0 and the other one is the Net28. So you can copy and paste the contents of these files. The only thing you need to be careful about is the IP address that you need to use for your 28 interface here, which should be your Prometheus's IP address. And then you should also create ENS33, and that should be standard and the same for all of them. Once you do this, you can do service network restart, and after that you can actually restart OVS as well. Or if you want to kill two birds with one stone, you can basically reboot Prometheus itself completely. It will restart everything. The correct OVS configuration will be in place. The correct configuration files for your networking will be in place. And then basically everything will start and you will get no error messages. Once you do this, your ifconfig should reveal that you have a Net28 network card with the correct IP address that you want instead of a BR0. And that will be in place of all of the info of the ENS33 network card. Once you have that in place, and once you type OVS VCTL show as well, and it shows you the VMNet28 bridge without any errors onto it, it means that you have created the one sort of physical, for us, network card that connects you to the outside world, and now we can create networks 30, 31, and 32. Always, before you actually create the ifconfig files and restart the network service, you need to create the devices in OVS. So it sort of works like a device driver, pretty much like VMware creates the VMnets when we're playing around with VMware virtualization. In the same way, OVS must have the correct configuration, and that's why we do this in the apparently wrong order for net28 as well. So the OVS commands need to run first, and then the configuration files, and then the restarting of the services. So you will need to create bridges VMnet 30, 31, and 32. And in order to do this, you're going to need these 3 commands for each of them. So you can create VMnet 30, and that will basically create a network card net 30 onto it. And you can take the ifcfg net28 configuration file from etc/config network scripts, copy it, and change the IP addresses inside it to correspond to network 30. Once you do this, you can then add the bridges 31 and 32, copy the 30 configuration file to make net 31, net 32, change the IP addresses in there, and once you have all of the correct OVS settings and all of the correct files, you can hit service network restart, and that will basically give you an ifconfig that contains net 28, net 30, 31, and 32. Alright, so once you have that, you basically have the networking infrastructure on your Prometheus server completed, and you can then go inside the cloud and actually configure everything inside the cloud so that you can use it. What you will need to do is you need to go into the networks area, and you need to create the bridges VMnet 28, 30, 31, and 32. You will need to remove your current bridge that you have on the system, because that is no longer valid, because the configuration files for it have actually changed at the moment. And then you go on and you create nets 28, and then 30, 31, and 32. The instructions to do this are here. They're very simple. The IP addresses that you need to use are essentially all of the IP addresses that you know correspond to your computers. You consult the a2.net subnets file, and you figure out, of course, which two IP addresses belong to you for networks 30, 31, and 32. And network 28 will only need to have one IP address, which is the bridged IP address after Prometheus. In fact, this year, and for the benefits of the next labs that I will explain later on as well, you can actually have 2 bridged IP addresses for this interface, and the rule that we use for our bridges is always +50. So your actual physical host has an address from 1 to 48, so then your Prometheus virtual machines are that +50. Your first bridge inside the cloud will be that plus another 50, so if you're sitting on computer 6, then your first bridge inside the cloud will be 106, and you can actually go all the way up to 156, and you can use a second bridge inside the cloud as well. Okay, this means that the IP addresses in the lab up to the range of 200 are available for you to use. Please don't create a 4th bridge and go to 206, because then you'll start clashing with servers that we already have in the lab. Okay, so network 28 is that, and the networks 30, 31, and 32 are according to the IP addresses into the subnets PDF file. Once you do this, you will have all the network cards available inside the cloud, and from there on, you can do a little bit of routing. So this is a very condensed version of the routing lab sheet that we've used in the previous year. You can use Quagga, you can install it on Prometheus. You need to get the Zebra and OSPF-conf files. Examples of them exist in the routing utils folder on Moodle. Download them, configure them correctly with the correct IP addresses and everything, restart the services, enable packet forwarding and disable firewall, and you should have turned your Prometheus VM into a router. So now everything that you try to ping from anything inside subnets 30, 31, and 32 should actually be routed from your Prometheus VM onto the outside world. This means that any virtual machines that you build inside the cloud will then eventually be able to have internet access through Prometheus onto the rest of the world. Which then brings us to the last lab sheet for this, which is populating the cloud. So this lab sheet, it definitely will not take you 1 week to do. The idea behind this is to put into use everything that you've learned with regards to OpenNebula up to this point. So we've installed OpenNebula, so we know the basic principles of operation behind it, what a virtualization host is, what sort of networking capabilities we have, how we can build virtual machines, how everything works inside Soundstone and so on, and how we've actually networked everything together. So once you have this in place, you can actually start building your own cloud. The scenario that I want you to use for this one is that you're building a cloud for a department in the university. This means that you'll need to have virtual machines that correspond to different users with different levels of access, so different permissions and so on. And you need to make sure that you provide the correct infrastructure for all of this to happen. Now, this lab sheet itself, I'm quite flexible with what you need to do on it. Okay, you can create as many virtual machines as you like, as many user accounts, as many types of user accounts. You can pretty much do whatever you want with this, as long as you adhere to 2 parameters. One, that your computer can run it. Yes, so don't try to build 25 virtual machines inside poor Prometheus. I don't think it's going to happen. Yeah. And 2, at the bare minimum, I want you to have 3 virtual machines in your cloud, and the specifications for these 3 virtual machines are as per this configuration here. So virtual machine 1 should be a file server, and it should essentially be the server of the cloud. You can set up authentication, you can set up file services, you can do whatever you want to it, as long as it's accessible from all of the other virtual machines in the cloud. You can set it up on net 30 if you like, or in fact, and because we do have the IP addresses available now in bridges, you can set it up on net 28 and use it there. It's totally up to you. Both of them will be awarded the same amount of marks, so it's fine. Whatever you think is most easier to do or most logical for you to do, as long as you explain why you're doing it, then it's fine by me. You can have a second server, or you can have a third server. So you can have a file server, you can have an authentication server using LDAP, you can have anything you like. You can expand on this as much as you like, as long as at the bare minimum you have a file server to provide remote shared directories for your users to work on. And I would like you to have a lecturer client and a student client. So this will be different VMs. I would like them to be segregated into different subnets. So I would like VMnet 31 maybe for the lecturers, and then net 32 for the students. Okay, and you can possibly implement something in here to actually not allow anybody from a student VM to have access to any of the lecturer VMs. Of course, the easiest way to do this is through access control lists inside the cloud itself. So you give your users the correct permissions for all of the resources that you have available in the cloud. Okay, and you will end up with virtual machines that the users that are allowed to use them can actually use them. All right, so the lecturers' computers should be sort of persistent, so they should be able to log in, work on them, use some information, whatever information they change on them, it stays there, and that's it, because they will come back and they will have, they work there and they want to keep all the information that they're using. Whereas the client VMs, I would like them to start up being used by the students, let's say remotely when they're working from home, and then any information inside those student clients should not be maintained. At its most basic form, all of the VMs should essentially be reset once the students log out back to their initial form. This doesn't automatically mean that the students will lose their work, because you can set up a share in the file data store, for example, where the students' local accounts and home directories will be kept. So once you sort out file sharing on the file server and user authentication, for example, with LDAP, then you can actually get those students to log into any of the student VMs, work. All of their work will be saved onto the home folders. It is essentially saved somewhere else, and the VMs themselves will be clean and can be used by anybody else without any issues. Once you've reached that point, you've pretty much replicated the university's network with regard to how you actually use our computers here. Okay, this is exactly what happens. So if you use one of the computers in 822 or 823 and you log in with your UP student number, nothing of what you do there is actually saved on the local computer itself. Okay, everything is saved in your profile, in your roaming profile, on our file server somewhere in one of our data centers. The computers themselves, if you log in, work, change the wallpaper, move the icons around, whatever, if you log out, they reset back to what they were. If somebody else logs in, they get their own desktop and their own settings and everything else. Okay, so this is exactly the same infrastructure, only in this case, these virtual machines can be accessed remotely through the cloud from the student's home, and then they don't have to come here. Okay, so this is basically the principle of operation of a cloud. You can have a cloud resource available anywhere you are, and you can use it as if you were actually back at work or at uni doing anything that you want to be doing. How far you can take this system is completely up to you. As long as your users can log in and work, then all of the little nuances of where their data is actually being saved and how actually everything works will simply add additional marks to the lab sheet, to the work itself. Okay, so for this lab sheet, if you create a bare minimum of those 3 virtual machines, you have 1 lecturer, 1 student, and they can log in and work, then you can get up to 70% for this lab sheet. All right, anything more than that will get you more marks for this lab sheet itself, and especially if you build something stupendously impressive, that will affect your entire logbook mark in the end as well. Okay, so for example, you cannot really get something like a 90% in the logbook unless you've done something spectacular with this last lab sheet, no matter how perfect all the previous lab sheets are. Okay, so the whole point of this is, like, the final destination for this set of lab sheets is for you to build a cloud system. All right, so how good you will build this depends on you having learned everything else that leads up to this lab sheet. Okay, of course, you can create more different types of virtual machines other than just lecturer and student. You can create other virtual machines. You can create researchers, visitors, whatever you like. You can put them on whatever network you like. As long as you justify your selection and your choices for this, you can do whatever you like with the cloud itself. Okay, so I'm gonna hit stop here.